Welcome back to the Data Analyst. In today's video, we are going to explore a fundamental statistical concept, odds and the odds ratio. These tools are essential in comparing the likelihood of outcome, especially when analyzing binary data. We will start with the definition, then move on to the formulas, working through an example, and finally explain how to perform hypothesis test for the odds ratio. Let's start with the concept of odds. When dealing with binary outcomes like success versus failure or yes versus no, the odds of the success are defined as odds equal probability of success divided by 1 minus probability of success. This tells us the ratio of the probability of an event happening to the probability of its not happening. Suppose the probability of success in a clinical trial is 0.6. Then the odds of success are 0.6 divided by 1 minus 0.6 equals 0.6 divided by 0.4 equal 1.5. So the odds are 1.5 to 1, meaning 1.5 chances of success for every one failure. What is the odds ratio? When comparing two groups, we use the odds ratio, which is the ratio of the odds of success in one group to the odds of success in another group. If group 1 has a success probability of Pi and group 2 has a success probability of P2, then the odds ratio psi is given by psi equal P1 divided by 1 minus P1 divided by P2 divided 1 minus P2. This compares the odds of success in group 1 to group 2. We often estimate odds ratio using a 2 by 2 contingency table. Suppose you have data organized like this. Then the estimated odds of success in group 1 is P1 hat. Normally we use P1 for odds of success. In here, we use P1 hat for estimated odds of success. So our P1 hat equal A divided by A plus B. And in group 2, P2 hat equals C divided by C plus D. So the estimated odds ratio is psi hat equal A multiply D divided by B multiply C. This shortcut method is based on the crop product of the table. Let's walk through a quick example. Suppose we have the following data. So our A equal 40, B equal 60, C equal 20 and D equal 80. So our psi hat equal 40 multiply 80 divided by 60 multiply 20 equal 3200 divided by 1200 equal 2.67. So the odds of success are 2.67 times higher in the treatment group than in the control group. Let's see how to get confidence interval for odds ratio. To assess the precision of our estimate, we compute a confidence interval for a log of the odds ratio. This is the formula for calculate standard error. Then we build 95% confidence interval using log psi hat plus or minus z value multiply standard error, where z equal 1.96 for a 95 confidence level. Exponentiating the lower and upper bound gives the CI for psi. Hypothesis test for odds ratio. Now let's test whether there is a significant difference in odds between the two groups. So in here, our null hypothesis is psi equal 1, no difference in odds. Alternative hypothesis, psi not equal to 1, there is a difference. Test statistic formula to calculate Z. After calculating Z, we have to get a critical Z value and we have to compare both of them. Compare the calculate Z value with the critical value from the standard normal distribution. If calculated Z value greater than 1.96 critical Z value, reject H0. If calculated Z value less than or equal to 1.96, we fail to reject H0. This helps determine whether the observed odds ratio is statistically significant. Let's recap what we learned so far. Odds show the chance of an event relative to its complement. Odds ratio, compare odds between two groups. Use AD divided by BC for quick OR calculation. Use confidence interval or hypothesis test to judge significance. If OR equal 1, there is no association. If OR greater than 1 or OR less than 1 implies increased or decreased odds.